And welcome back. Now this is a continuation sort of a previous video or two where we talked about power saving in the Arduino. We ended up with this device plugged into a breadboard, and I said that this is probably worth a little video, should be short, but you know me, to actually construct this, because it's very, very easy, and more to the point, this is the only way you're really going to get any power savings, because the Arduino board, like that one at the back there, you'll never get the power savings required to run it off batteries. Alright, you can run an Arduino Uno or something like it in a robot car with some lithium cells attached to it, and yes, it will run for half an hour. What I'm talking about here is running a circuit like this one on here now, that is mainly asleep, in deep sleep, doing absolutely nothing, taking microamps of power, and then every now and again waking up like this one does to flash that LED, which is simply representative of actually doing some real work, like checking temperature sensors or water tank levels, and if necessary taking the required action if something's not quite right, like emailing you or I don't know, sounding an alarm. Whatever the point is that for 99.9% of the time this chip will be asleep, as in fact this one is. Now this is the exact design that was constructed as part of the deep sleep video in 116. That's the one on screen now, and well, it's been running ever since, frankly, and as you can see, all it's doing is flashing that little LED. It does in fact flash it twice in real life. Occasionally, and I don't know why, the video camera misses the second pulse, so it looks like a single pulse, but there we are. So that's been asleep for several days now, flashing that thing every now and again, every 4 seconds was it, something like that. So what we're going to do is discover how we can build this with a view to creating your standard Arduino sketch as you would do normally, using a board like that one at the back there. So let's assume I actually wanted to build something like this eventually. I'd first of all build it using a standard Arduino board, so getting all the sensors measured and the corrective action taken and email sent, or whatever it is you're going to do. And when it's absolutely done, as the expression goes, then you program this chip and put it on a circuit board and go, that's it, now the deep sleep bit will actually do some real good, and you can run it off a battery like this one. This one we discussed in video 115, and to be quite honest, I'm pretty impressed with this, because for any circuit that for the most part is sleeping, this sort of battery is going to last for absolutely, well, weeks and weeks. Now I've got it plugged into the 5-volt side. You could plug it into the 3-volt side, but then you'd have to almost certainly reduce the speed. This is still running at 16 meg. We could remove that crystal and the 2 capacitors associated with it and run it off the 8 megahertz clock that's internal to the chip, and that would actually save more power, because then you would run it off 3 volts, and at 3 volts it consumes less current, even less current, I must say. But this video is all about how we get to this stage. Having created your Arduino, as I've said, you know, in the code, and it's all working, how do we get a bare naked ATmega328P chip? It must be the P variant, okay, 38P, because that's the pico power, the thing that does put it into really deep sleep. How do we get this chip up to the same coding level as the one at the back there? Now these days, when you buy an Arduino board, it's highly unlikely you're going to get a DIL chip like this, dual inline. They're almost certainly going to be surface mounted like that one at the back, so you can't just unplug one and plug it back into another board. But it's very, very easy to do this. We first of all have to put the bootloader on, that's step 1. Secondly, we have to put the code on it, that's step 2. Step 3 is the end. That's it, that's all we have to do. So let's go through those simple steps one by one and get back to this level. I'll disassemble this and put it on this other breadboard over here as we go through step by step. Okay, step 1 then. Let's load the bootloader onto here. Right, step 1 is burning the bootloader, and here we have the chicken and egg situation really, because you do need a proper Arduino Uno. Like that board at the back, can be a clone, doesn't matter, but you do need one in order to be able to do this. So, and let's face it, in the bigger scheme of things, it's unlikely you'll be trying to do this without already having an Arduino somewhere that you're currently working on, because as I say, it's easy to develop on a board like that but if you want to save the power, this is what you've got to use. So grab yourself your Arduino Uno, clone or otherwise. It can be a Nano, incidentally, if you need it to be. Have I got one? Just looking. Yes, here we are. That's a Nano, but plugged into a development board, just to make it easier to get hold of the pins. So a Nano or an Uno for this will be absolutely fine. And what do you need to do? Well, first of all, you need to turn this board into a programmer, which is very simple. You just upload a particular sketch to it as supplied by Arduino CC. So let's fire up the Arduino IDE and see what we come up with. Right, so this is the Arduino IDE, nothing loaded on it yet, but we're going to load up a sketch as supplied by Arduino themselves, and I'm guessing that every now and again it might get tweaked a little bit to cater for newer boards, I don't know. So File, Examples, Arduino ISP, Arduino ISP, that's it. So just click that, it will load up a new instance, we'll close that one down and use this one. So this, I mean, you can read it by all means, but I'm not going to. But it's basically what it does is upload onto your Arduino code that turns it into a programmer for one of these. So it's all a bit incestuous, isn't it, that relationship? But that's fine. And you just select the board you've got. That's this board. It's just like a normal sketch at this point, remember. So yes, we have got a Genuino Uno. Well, it's not. It's a clone, but they don't know. Port. Nothing yet because I haven't actually plugged it in, so let's plug that in. So we're just going to now upload that and off it goes. Right, so that's loaded. So what we've actually done at this stage is sort of part one of step one. We've got the sketch required on here that will then be used to upload a bootloader onto here. Now that is equally easy, because now all we've got to do is go back to the monitor so you can see everything. Now on here we say now, so what's our target board? What do we want this to emulate? Is it going to be a Nano? Is it going to be a Uno? Well, I'm going to leave it as Uno. Yeah, and it's still COM13. And we say burn bootloader. So that's going to burn it's going to tell this basically to burn the bootloader onto this. So let's click that, fingers crossed. And there it goes, writing various bits and pieces and fuse, and it was very quick, wasn't it? It's a very short program, let's face it. So that's it, done. Well, that was a quick step one, wasn't it, really? Well, it was so quick that in fact we got time to have a look at a bit more detail into the wiring. So here's a picture. This picture will be available in the GitHub as a separate JPEG or something, so you can print that off. And as you can see, there's only 4 wires plus 2 power. So it's all pretty simple, really. I won't go through it here. You can read it as well as I can. Okay, I think we're done here. Let's move on. Right, on to step 2. Having got the bootloader loaded on our absolute minimalist circuit, as you can see there, decoupling capacitor at the top between the power pins, and remember we've only powered up one side of this, so the analog side is not yet powered. It's powered here with the decoupling capacitor, the 16 megahertz crystal, and the 2 capacitors that form part of the oscillation circuit with the crystal, and power, and that's it. Okay, bootloader's on. Next step is to get one of these. Now this is an FTDI USB to serial converter. Some Arduino boards like this one at the back here used to have these on here. They've moved away from FTDI due to the issues that were around FTDI chips and moved on to the CH340G. The FTDI chip apparently was cloned by Far Eastern manufacturers, and FTDI didn't like that, so they effectively sent out some code, drivers ostensibly, and when it detected it wasn't a proper chip, it bricked it. Yes. And of course the poor unsuspecting consumer had no idea it wasn't a real chip, so they were left with a board that frankly didn't work anymore. Now they could still program it via the ISCP ports, but yeah, it's not nice, was it? So anyway, the manufacturers of the clone boards have all gone to CH340G, but what you do need still is this FTDI or 340G USB to serial converter. Now This one here, as you can probably make out, there's a jumper on there. Right, you can just make out there now, look, 5 volt it says one side and 3.3 the other side of that jumper, and there's the FTDI chip bang in the middle. Okay, so what that means is you really must get this dual voltage version. Don't just get the 5 volt version, because that will hamper you in future endeavours for other chips. So I bought this years ago now, and jolly glad I am that I did. So all you do is remove the jumper from one side to the other. So you either say 3.3, you put it on one side, and 5 volts the other. Now we are still programming in 5 volts because this chip is 5 volt tolerant. It will run from 1.8 volts though, depending on the frequency. But we're going to program at 5 volts. And I'll show you where you can get these, but don't be tempted into getting the single voltage version, even though it's cheaper, because this has served me so well over the years. It will be false economy just to get the fixed 5 volt version. You definitely want both. Now it's a 6-pin output, but we're only using 5 of those pins. So let me see if I can get a bit closer in for those as well. Right, so the pins there from left to right are DTR, which we need. That's data ready. Receive, RX, TX, transmit, VCC, which is 5 volts, to your Arduino. CTS, clear to send, we're not using that one. And ground on the very right here, we're using that. So those are the pins we're using, and I've sort of color coded them. Brown for ground, seems fairly okay. Red for VCC, and the others are just, well, arbitrary colors really, but they're the ones I'm using. Okay, so the orange is TX, yellow is RX, and DTR is green. Now, do not forget that the chip that we're about to connect to behind here also has a TX and RX, but the TX goes to the RX, and the RX here goes to the TX on here. It's an easy thing to miss or get confused about, and then you wonder why your chip doesn't respond. So let me connect up these wires and I'll tell you exactly where they go. Don't worry, there will be a diagram as part of this video. I'll drop it in, and it's very easy to do. Okay, so there's only 5 wires in, 2 of those are power. So let me do that, and we'll move on. Right, step 1 then, before we connect those wires, is that you must connect a 10k resistor to pin 1 of your chip, and also get this capacitor ready. It's a 0.1, you might be able to make out, it says 104. Just in case you don't know, when these capacitor markings, when it says 104 like that, it means 10 followed by 4 zeros, and that's in PFs, which actually makes it 0.1 microfarad. There's a very useful capacitor translation table that I use, because if you think I can keep in my head all those NFs, PFs, microfarads and everything else, forget it. I'll try and put a snapshot of that on this video as well. But anyway, it's a 0.1 capacitor, 10k from pin 1 to positive. Oh look, error. That's going to ground. That's no good. It's supposed to be a pull-up resistor, so I'm going to change that. It's got to go to plus 5 volts, which is what your Arduino board does for you. So on here, on pin 1, there's already a pull-up resistor. Okay, so that's the first thing to do, and now I'm going to connect the cables and correct that resistor. Right, here we are connected up then. Not that anything magic is happening just yet. The FTDI board, when you connect this up, even before you've connected any pins on here, will enumerate, and you'll find something in your ports list, which is always something good to check. Now, what could go wrong at this stage? Well, I've had it just recently a couple of times where the USB cable I'm using is just a, well, it appears to be just a charging USB cable. So you plug it in, the red light comes on down here, and you don't get that little Windows or Mac sound saying I've just found another USB device. So always check your ports window, this one here. So this is your device manager now, and if I've opened up the ports, and as you can see there's an Arduino Leonardo on COM4. That is in fact my video switching device, which we covered in a video many years ago now. I don't know what this one is. This one on COM3, some Intel thing is always present, so it's something internal to the machine, I'm guessing. And this is the one here, USB serial port 8. Okay, now how do I know this? If you've just connected this in, you load this up, and maybe there might be half a dozen things in it. Well, if I switch off my video switching one, that top one should disappear. There was the noise, the Windows says something's changed, and it's gone. Okay, now this one hasn't gone because, as I say, this one is permanently present, and that one hasn't gone. But if I do disconnect it, you get the window sound and it's gone. So when I connect it back up, there it is, COM8. Okay, now it might change if you plug that into a different USB port every time. It will change, so try and keep it in the same one while you're sort of mucking about. Okay, that's the first thing then. That's great. Now we need to program it and upload the code, so that's the very next step. Right, we're ready to upload our code. Now I've put a resistor. This is a 180 ohm resistor from GPIO pin 13, which is actually a physical pin 19. Let me just show you the pin mapping here. We covered this in one of the previous videos that I talked about. Here we are. Here's the pin mapping, and we're looking at digital pin 13 because that's what's going to be expected by the Arduino sketch. The built-in LED on your Uno is expected to be on digital pin 13, so the code will refer to that, but we need that, and it's going to be on pin 19, physical pin 19. So what I've done here, as you can probably see, is that connect a resistor from pin 19, a 180 ohm resistor from there just outside, and then connect an LED plus side on here. Okay, anode this side, cathode down here. Now, is this going to work as it stands? No, it's not, because I've realized that this line here is in fact not connected to the negative here, is it? Because we haven't supplied any power yet to the analog side of this chip, and we don't need to. Okay, if you remember the video 116 and indeed 115, we said we switch off the power to the analog conversion as part of our power saving routines, so that at the moment we could not do an analog read on pins A0 through A5. But we don't need to, do we? Why would we want to do that at the moment? Well, we don't, so therefore we simply don't supply power to this part of the chip. However, I do need to supply power, or at least a ground connection from this. So I'm going to just quickly put in a connection from here to here. Okay, negative to negative, or yep. And then we're going to upload the code. Now, the code we're going to upload is this one here, using the Arduino sketch. So the way you load up the Blink program, as an example, it's File, Examples, Basics, Blink. Click that, and you'll get this. Okay, now the first thing you've got to tell it is which port your Arduino's on, or in this case, what port the FTDI converter's on. So go into Tools at the top of the menu there. Make sure you've selected your Genuino Arduino board, which it is, and that it's on the correct port. Well, ours is. Look, it's on COM8. That's fine. So we should be good to go. So simply uploading now, we should see down the bottom here the correct, well, debugging kind of statements when it does it. So let me switch back to the code window to get a better view of that. Right, here we are then on the code window. I'm going to make this a little bit bigger down the bottom because I'm not really interested about the code. I mean, you can read that as well as anybody. It's just a simple bit of code just to prove that what we've got down here is all going to hang together. So just by now pressing the upload button on there, we should see some things spring into life. The exciting bit is not the compiling. This is obviously compiling it for the very first time. It's when it tries to actually upload it via the FTDI converter. So this point here. Oh, look, you get all these bits here and it goes, yeah, I've done it. Great. Let's zoom in on the board and see what's happening down there. And here we are. Right, so I've added that link in, the missing link, the minus, negative. And as you can see, it's actually blinking. So once you've got to this stage, you can say, ta-da! It's working. You've now successfully got an Arduino on this board, and of course, as I say, it's a little bit fiddly to get it all up and running initially, but it's easy though, isn't it? It's not difficult. It just has to follow a certain number of steps. Now, if you were doing this regularly, I suspect that what would be a good idea is to get yourself a proper little programming board that you can make up yourself using stripboard or something, and put one of those zero force insertion sockets on that board for this size DIL socket, so that you can drop these in and out very easily. Let me show you what a DIL socket looks like. Right, so this is a wide-bodied DIL socket, not one we want for this. That's much smaller than this. This is from my PIC days, in fact. What's that in there? Right, that's a PIC 18F4550. Fancy that. God, it's been a while since I've programmed any of those. But anyway, that's a wide-bodied DIL socket, and that's not the one we want at all. It's too big. What you actually want is this width, but as you can see, that's not big enough for that. You need a 28-pin DIL socket. Now, you can get these off the internet, so we'll have a look about that and just see how easy it is to pick one of these up. Also, while we're on the subject, if you go to the eBay site or somewhere like that, you'll find these chips available with the bootloader already loaded on for you to make life easier, because obviously that's the fiddly bit, isn't it? But you can put it on yourself, obviously, as we've just done, but it does make life a lot easier. You can go straight to this step with the FTDI and load your code, and that's all you need to do. Now, if you were to have a commercial venture and go to Microchip and say, I want 1,000 of these, they give you the option of actually uploading the code for you, and it costs, I don't know, I think it's about 15 cents a time or something like that. But if you were a small startup business or entrepreneur, it would make an awful lot of sense to let them load that code on there for you, because, well, can you imagine if you had 1,000 of these chips arrive and you've got to load each one, even if you had a ZIF socket like this and just drop them in, it's going to take you absolutely forever, and I suspect the time would be better spent elsewhere. Right, that's that. Let's load up now the actual circuit we had on here for the deep sleep. So still an LED, although it came out of a different pin, didn't it? Pin 4, and then this goes to sleep, and we'll measure the current again to make sure it all hangs together. Right, so here's the Arduino IDE, and I've just put the code in there. We haven't actually saved this code under the Arduino IDE, it's only under Eclipse. So let's see if it will upload or not. Compiling away. That says it wants to upload. Oh look, it is uploading perfectly all right. And there we are. Well, that's it. We've reached the end of the video though, because that's now flashing every X seconds. I think it is every 4, isn't it? There it goes. And sleep most of the time. And that's using, well, let's have a look at the, whoops. Let's just have a look at the meter over here and just see how much power it is using. Right, here we are 30 minutes later, because I blew the fuse at my micro meter there. So this thing over here, as you see, it's on microamps. I already had it set to microamps from the previous video, and forgot that I had the FTDI running on it, and it was taking, I don't know, 40-50 milliamps. It didn't like that at all. Funnily enough, the fuse internally was 500 milliamps, but it still blew anyway. Luckily, it saved the meter. So anyway, now we have this connected up, and as you can see that I've left the LED on at the moment, but it's taking what, 27 milliamps it says there. Let it settle down. So 27 microamps in sleep mode, and the extra current is only taken when that LED blinks. So let me remove that and we'll see what happens then. Right, it should stabilise now. We'll go up a little bit when the pin goes high. There we are, 350 microamps. But for the most part, about 27 microamps, as we had it in the previous sketch. No surprises there. Right, a very quick look then to see where we can get these chips from, with or without a bootloader. I've gone onto AliExpress. These sellers will also sell on eBay, of course. So let's have a quick look. So this one, I'm just seeing here, it says the word bootloader in that title. So that's £1.42. Let's have a look what else they give you, if anything. No, that looks like it's just the chip, no crystal or capacitors. So move away from that one. Now, here's a little interesting thing. Look, this has got the socket on there that we're talking about, the ZIF socket, and a little buzzer, and the crystal. So maybe that's like a shield you can plug in by the looks of it. Oh, it says high-speed shield burning bootloader. Fine. So maybe that's a really, really easy way of doing it. Is put a shield on top of your standard Uno, and well, play away. And for £2.89, is there any postage on that? No. Do you know what? I'm almost tempted to get that, just for the odd occasion when I'm going to be uploading stuff to the actual chip, and I suspect I might need a couple for my workshop automation project. So yeah, that's sort of something I'll look into a bit more. Yeah, okay, let's see what else they got elsewhere. So I've gone into eBay UK, but you can bet your bottom dollar that people selling on here from China are going to be selling absolutely on every single platform there is. So here's one. This is the chip with the bootloader already on it, says. 60 megahertz crystal, and the two caps are pretty much what I got there. Now you can buy the crystal and the capacitors separately, but remember that when you're running this thing you can run at 8 megahertz from the internal chip as well, but you can't do that initially. It's got to be running from the crystal if you're buying it with the bootloader, because that's what it's been programmed to expect. Okay, well that's not bad, is it? $2.99. You can probably get it cheaper than that from the Far East, so let's keep having a look. And here's another one for $2.95. Now this is in fact a UK seller for $2.95, so you get a socket, the capacitors, crystal and chip. Has that got a bootloader on it? Yes, with a bootloader it says. So for $2.95. Now funnily enough, that is still more expensive, is it not, than a brand new cloned Arduino Uno or indeed Nano, you know, the whole caboodle. It's still more expensive because I can buy a Nano or indeed an Uno for about £2, whole thing. So it's not cheap if you buy it locally, is it? Let's see if there's a Chinese seller on here. Well, there's certainly lots of ATmega328Ps for sale at a very low price, like this one here, which is £1.22, but it doesn't contain the bootloader. Not that really you should care anymore, because you can upload your own bootloader. And more to the point, in uploading your own bootloader you can say, I don't want it to run with a crystal, let it run with the 8 megahertz internal clock, because then you're saving yourself 3 components, and you can run it from a 3 volt supply then as well instead of a 5 volt. But I'm sure you can browse the internet as well as I can, but it does give you an idea of the sort of things that are out there, doesn't it? Cool. Good. Right, that brings us to the end of this board then, so it's very easy to set up. Very easy to load your bootloader and code on it, and the bootloader of course only has to be done once, so it's a one-time operation. There we are. Super duper. Easy for you to do, save a bit of battery power, and we're running on this at the moment, so it is battery. Good. If you like the video, don't forget to give me a thumbs up, and do read the comments below the video as well, or any links and things I'll put down there. Okay, see you in the next video. Thanks for watching. I hope you're finding these videos useful and interesting. There are plenty more videos to choose, and a couple are shown below. And if you'd like to subscribe to this channel, just click on my picture below and enjoy the rest of the videos. Thanks for watching.